What do these have in common with this? Hi, I'm Dave Dooling, Education Director at the New Mexico Museum of Space History. Today, for Solar Week, I'm taking you to the dark side of the sun. Dark side doesn't mean the other side. It means a powerful side that we have only known about for a century and still don't understand. The first big discovery about the sun in modern science was 400 years ago when Galileo and others discovered that the sun had spots that changed with time. Scientists puzzled over it for the next 3 centuries and offered different explanations. They are openings to a cool interior. They are caused by asteroids crashing into a burning sea. But nothing made sense until 1908, when George Ellery Hale was studying the sun with his invention, the spectroheliograph. This let him make pictures of the sun in very narrow colors. When he looked in H-alpha, a deep red color made by hot hydrogen, he saw swirling patterns. These reminded him of when he was a child playing with iron filings on a sheet of paper over a magnet. This strengthened the suspicion that magnetism played a role in solar activity. But how to detect it? Magnetism is invisible. Peter Zeeman of the Netherlands had found the answer in 1898. He discovered that strong magnetic fields make hot gases produce multiple spectral lines instead of one. Hale decided to use Zeeman's discovery. First, he repeated Zeeman's work to make sure he understood it properly. Then he studied the light from a sunspot in a deep red color produced by superhot iron gas. On the face of the sun, he saw a single spectral line. But inside a sunspot, he was rewarded with the appearance of 3 lines, just like those in Zeeman's experiments. That showed the presence of a magnetic field more than 1,000 times stronger than what we have here at the surface of Earth. It was the most important solar discovery since sunspots. But how could this be? The sun is mostly hydrogen and helium, which are not magnetic. Iron is just a very tiny part. It's because 1 + 1 = 3. That's not new math. That's how magnetism, electricity, and motion work together. If you have 2, you make the third. Move a magnetic field across a wire, and you get electricity. Run an electric current across a magnetic field, and you get motion. Move an electric current, and you produce a magnetic field. And that's how it works on the sun as electrified gases circulate. When it gets thin enough, it cools by shining light into space and sinks to the interior. The moving electrons generate magnetic fields that cause a range of beautiful effects. First, of course, are sunspots. Spots are not black, but cool regions where a magnetic flux tube from the inside of the sun keeps cooled gas from sinking. The surface of the sun is almost 10,000 degrees hot, and the interior of a spot is a chilly 7,000 to 8,000 degrees. The spots usually come in pairs with opposite magnetic polarity, so one is north sense and the other is south. Magnetic fields arc out of the sun into space and connect to the other spot. Spots appear and disappear during the 11-year sunspot cycle. Magnetic lines get pulled in 3 directions at once, from inside to out, from equator to poles, and as the sun rotates faster at the equator than near the poles. Eventually, it looks like a ball of yarn worked over by a cat. The magnetic field slowly collapses, north and south magnetic fields trade places, and it starts over. So it's really a 22-year cycle. And it's more than spots. The beautiful, delicate tracings you see during a solar eclipse are caused by hot, electrified gases trapped along magnetic field lines. We see these in X-rays as coronal loops and flares. Again, the magnetism is invisible, but we easily see superhot gases trapped along the field lines. Solar storms like a coronal mass ejections belched from the sun can sweep past Earth's magnetic field and produce the auroras. They can also short-circuit communications and power grids. It's all driven by the same invisible force that holds those souvenirs to the refrigerator. And even though we've known about it for a century, we're still just learning how to study it. Stand by for more discoveries from space probes and telescopes on Earth. Thanks for watching, and stay tuned for more stories from space.